Today we are in lesson 2.3. We're on page 78 in our books. Page 78. Simplifying. Simplifying. There is a difference between simplifying something and solving or evaluating. Did you know that? So when I'm simplifying these expressions today, there is no answer because I don't have a value for these variables. If I had a value, I could substitute and solve, but I don't. So it's important, guys, that you're not looking for an answer. Every year I have kids that they can't get past that. They're like, I've got to have one answer, but that's not how it's going to be, okay? Because I don't know the value for the variables. All right, so before we get started, I want to go over some terms with you, some vocab words that you need to know. So within an expression, all right, I want you to write this expression down. 5x minus 4x plus 7, okay? And we'll basically pick out what each one of these vocab words, what each part of it is. Okay, so terms are the parts of an expression, all right? You had a minute to go ahead and write down that definition. So I want you to identify each term in this expression. What does that mean? That means 5x, 4x, negative 4x, it's negative, and 7. Okay? I'm just saying what it is. All right? Each term. So it's an individual part of the expression. And then we have like terms. Well, like terms are the parts of the expression that can be simplified. They can be combined. So it has either the same variable or it's the number by itself. It has no variable. Do we see a set of like terms here? Jared?
5x and 4x?
Not 5x and 4x, but what, Alex?
5x and 7 because they're both positive.
No. Emily?
5x and negative 4x?
Yes. 5x and negative 4x. So in parentheses, I'm going to identify that my like terms are 5x and negative 4x, and I separate them with a comma. Does 7 have a like term? No. So it's by itself. So I don't list it as a like term because it's just the term by itself. All right, what about constants? So a constant term is a number by itself. It has no variable. Do I see a constant here in that expression? 7. And I call it a constant because 7 has a value. Will it ever be anything but 7? No, it's just 7. There is nothing that can affect its value. So numbers by themselves are what we call constants because their value never changes. 5 is 5 no matter which way I look at it, right? Okay, and then we have a coefficient. A coefficient, it has to be in a term with a variable. And it is the number only, okay? So I look at my terms that have variables, like 5x, okay? In the term 5x, 5 is my coefficient because it is the numerical part of the term, okay? So it's the number only. So my coefficients would be 5, and anybody have a guess at the other one? And negative 4. 5 and negative 4, because in my terms with variables, it's the number part of that term. It's the numerical part, 5 and negative 4. All right, so those are basically just the individual vocabulary words and definitions that you need to know for this lesson. All right, example 1. Identifying the parts of an expression. So you have a couple homework questions tonight that give you an expression and they want you to just break it down. All right, so the first thing I'm going to do A with you, okay, is I'm going to identify each individual term. So same with me if you know. Y, 8, negative 5y, and negative 3. I'm just identifying each individual part of the expression. That's it. Now for my like terms, I'm going to group in parentheses the terms that I could simplify if I was simplifying the expression. So I see a y. Is there another term with a y?
5y.
Not 5y. negative 5y. So if it's negative in the original expression, it's got to be negative when I group it. Y, comma, negative 5y. Is there another pair of like terms? Alex?
8, negative 3.
Do you agree with him? Jonadab, do you agree? 8 and negative 3? Why is 3 negative? Why isn't it positive? Because it has a negative sign in front of it. Okay, so I can't ignore that. 8 has a positive sign in front of it. 8 and negative 3. Now I have my constants. My constants are numbers that stand alone. Anybody see any numbers? Eric? Yeah, go ahead. Andrew? 8 and?
1.
Nope. Anybody see another constant? Laria? Negative 3. 8 and negative 3. Those are my constants. They're numbers that stand alone. Anybody see a coefficient? Coefficient?
5, negative 5.
Negative 5. Very good. There's one more. Do you guys remember what I taught you the other day about a variable that stands alone? What is understood to be in front of that variable? A 1. So since I know that there's an understood 1 in front of y, I'm going to identify 1 as another coefficient. Okay? So be careful on those. You've got to identify that understood 1. That is a coefficient. All right, now that I've identified the parts, I'm going to combine my like terms. Guys, it's important here that you pay attention to the sign in front of the term. We just said that there's an understood 1 in front of the y. So what is 1y minus 5y? What's 1 minus 5? Negative 4y. Very good. So when I simplify, it's negative 4y. And now I'm going to simplify my numbers. What's 8 minus 3? Positive or negative?
Negative. Positive 5.
Why is it positive? Because 8 is bigger. Plus 5. And that's my answer. All right, I want you to do the second expression, x minus 4 plus 3x minus 7, the same way. Identify terms, like terms, constants, coefficients, and then simplify. Okay, so let's go over them. Terms, same with me. X, negative 4, 3x, negative 7. Like terms, x and 3x, negative 4 and negative 7. Did you remember your negatives? Okay, did you remember your negatives? Now your constants are negative 4 and negative 7. Your coefficients are 1 and 3. And when you simplify, you get 4x minus 11. All right, now in example 2, they don't make you identify all the different parts. They're just asking you to simplify the expression. All right, now what you have to remember, though, is you can only simplify the like terms and pay attention to the sign in front of the term. Let's look at the first one. 4n. Are there any other n's? Yes, there is. There is a positive or a negative n. Negative, what do I know is understood in front of it? A 1. So what is 4 minus 1? 3n. Okay, now I have... Do I have any other terms I could combine? Negative 7. And is that a positive 9 or a negative 9? Positive. So what's negative 7 plus 9? 2. 3n plus 2. Can I combine them anymore? Nope. 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 You can't. The reason why is because these are not like terms. This is my simplified answer. That's why I was saying at the beginning of the lesson, there's not going to be an answer here. Okay? All I'm doing is just simplifying it as much as I can. I'm combining my like terms, and then that's my answer. All right, that's it. I want you to go ahead and try B. See who can get B right. What's 8x plus x?
9x.
What's 22 minus 10?
12.
Positive or negative? Positive. Who got it right? Okay, good. But that's not everybody. Anybody have a question? Questions? Any questions? Do you see where you did what you did wrong? Okay, on C, has anybody already done it?
Yes.
Okay, good. All right, I've got a lot of negatives here. Is 3x positive or negative?
Negative.
Is x positive or negative?
Negative.
So what's 3x minus 1x?
4x.
Negative 4x. Add and keep. What about 8 minus 4? Whoa, whoa, whoa. 8's positive. Negative 4x plus 4. All right, just simplifying the expressions. Once you kind of get in the habit of making sure you're just looking at the signs in front of the terms, it makes it a lot easier. Of course, you have to know how to add and subtract integers, okay, and hopefully we're good there. All right, so that's it for example 2. Now let's look at example 3. In example 3, what do you see? What do you see? You see parentheses. Oh, man. We have to distribute. Yes, we have to use the distributive property. Why? Because we cannot simplify what's inside the parentheses. But we have to get rid of them. Before we can simplify the expression, we have to get rid of parentheses. How do we do that? We distribute the 2. We multiply 2 times x and 2 times negative 4. What is 2 times x? 2x. What is 2 times negative 4? Negative 8. And now I bring down the rest of my expression, and my parentheses are gone because I've now distributed the 2. And now I can simplify my like terms. So when I simplify my like terms, I do 2x plus or minus 9x. Plus, because there's a positive sign in front of the 9x. So 2x plus 9x is 11x. And then negative 8 plus 1 is what? So it's minus 7. 11x minus 7 because it's negative 7. All right, I want you to try B. Okay, so 3k, whoops, not in red. That's not my answer. All right, so 3k minus what? 8k minus 16. Raise your hand if you got that step. Did you get that step? Distribute. Distribute. Now I can combine my like terms, and I get negative 5k, or not x, negative 5k minus 16. Who got it right?
Yes.
Okay, good. C is a little different because do you see a number? Is there a number in front of the parentheses? No, there's just a negative. So if there's only a negative, I'm going to write that it's an understood 1 here. All right, and now I'm going to distribute a negative 1 through to each term. So I have 4a minus 4a plus 3. Why plus 3? Why is it plus 3?
Because there's 2 negatives.
Because I'm multiplying negative 1 times negative 3, which is positive 3. Anybody see a number property here? Which one? Which number property can we apply here? Nope. Nope. Anybody see an opposite? Do you see an opposite here? What? 4a minus 4a. What happens? Inverse property of addition. Take a number and its opposite, combine it, and it's always 0. So guess what my answer is? My answer is 3. Okay, my variables cancel. Huh? But the variable canceled out.
We simplified down to the answer.
Yeah, there is an answer on this one because my variable canceled, so I don't need to know what it equals. All right? Last example, finding perimeter. Okay, now when I'm finding perimeter, let's say I've got 3y, and over here I've got 2y plus 5. Well, what is the formula to find the perimeter of a rectangle? P equals 2 times the length plus 2 times the width. So now I'm going to plug it in. P equals 2 times my length, 2y plus 5, plus 2 times the width, which my width is 3y. Yeah, my length was 2y plus 5, so I multiply it by 2. And my width is 3y, so I multiply it by 2. All right, now what do you think you need to do? Distribute. Distribute it out. Okay, so P equals 4y plus 10 plus 6y. So that's my answer?
No.
Why? Why can't it be my answer?
Add the y.
I can simplify my like terms. Very good. So when I simplify, yep, 10y plus 10. And I'm just going to label it, it's 10, right? Yeah, units. Units, because I don't know which unit of measurement it was. Find the perimeter of a triangle.
P equals A plus B plus C.
P equals A plus B plus C. Let's say that we have...
That's an equilateral triangle.
All right, so don't worry about the how it looks. We're just pretending for a minute that it's not the same dimensions. P equals A plus B plus C. Okay, so P equals, I'm going to add my sides. A plus 4 plus 3A plus 6. All right, so that's my answer?
No.
Why not?
10 plus A.
I can combine my like terms. What's A plus A? 2A, because they both have understood ones in front of them. 2A, what's 2A plus 3A?
5A plus 10.
5A plus 10. Units. Make sure you label. If there is no other unit of measurement, just say units. Okay? All right, so that's going to help you on numbers 33, 34, and 35 on your homework tonight. If you understand that, that's everything you need to know for 2.3.